All right, hello Geometry B folks. I'm teacher Kevin. We're going to go over the Law of Cosines quiz version 2. So if you've already got this quiz, what I'm going to do to start with, I know this is a quiz on Law of Cosines, so you might guess that for these problems we need to use Law of Cosines, but many situations you might not know straight away to use Law of Sines or Law of Cosines. So what I'm going to do just to start with here is I'm going to try number one. I'm going to try to say, what if we use the law of sines? What if we try to use law of sines, and maybe we call this angle x and we call this angle y. So if we do law of sines, what that would look like here, we would have, remember, it's the sine of an angle over its opposite side length. And that fraction, that ratio, is equal for any triangle. Any angle, the sine of that angle is over its opposite side length is equal to the sine of any other angle over its opposite side length. So if we do the sine of 38 degrees over m, that would equal the sine of whatever angle y is, what I'm calling y, over 13 feet, and that would equal sine of x over its opposite side length of 18. So just again, if we didn't know if we should use law of sines or law of cosines, if you look at this, if you tried law of sines, what you're going to find is that this is not going to work, at least not to start with. You rule out any of these, ultimately we want to know what m is. If we rule out the middle fraction there, we have two variables. We have m, we have x. That's not going to help us solve for m. If we rule out the second fraction, or the last fraction rather, excuse me, still we have two unknown side lengths. So just if you wanted to try law of sines, it's not going to work. So if we're going to use anything to start solving this triangle, we need law of cosines. Okay, so if we apply the law of cosines, remember the idea is that we have an angle. We only know one angle, or we're only using one angle, and we're using the opposite side length. So in this case, the 38 degrees is angle C, and side length m being opposite would be side length C. A and B, those side lengths, the 13 feet and the 18 feet, those are interchangeable. Which one is A, which one is B, doesn't really matter. But if we plug these numbers into our formula, we would have m squared would equal 13 squared plus 18 squared minus 2 times 13 times 18 times the cosine of that angle of 38 degrees, all right? So looking at this equation that we have now, the right side is a bunch of numbers and operations. And this is where if you want to break it down, you can. I think just for brevity, just for being quick with this, I'm going to do this all on the calculator, and I'm just going to get one result to say m squared on the left is equal to one result for all of this here on the right. Okay, so if I do that all in the calculator, I get 124.210, etc. Again, you might break it down into parts, and that's fine, and you might get something slightly different, but you should get something close to 124 point something. But remember, that is m squared, and ultimately I don't want m squared, I want m, so I'm going to cancel this with a square root. So I'll take the square root of m squared, and I'll take the square root of that other side. And again, if I want to just leave that number on the calculator, and I can just say, calculator, please do the square root of that number, and then we're coming up with 11.144, etc. And then just the rounding here. What are our rounding instructions? Nearest tenth. So we're sitting at 11.1 with a 4 next to it. We have a value of m of 11.1. This would be 11.1 feet. Let me think here. We could talk about, is 11.1 reasonable for this result? Based on what we know, that's difficult. Based on what we've done in class, that's difficult because we've related, big side is opposite big angle, and small side is opposite small angle. And right now I only have one angle, so it's to say, well, hey, this is the small side. Well, is 38 degrees the small angle? That would be a question mark. I don't know the other two angles, so unless I do more work to figure out those other two unmarked angles, it's difficult for me to say whether or not this is reasonable, at least based on what we've done in class at the time of this, the recording of this video. So I'm going to just take 11.1 feet as my answer, and I'm going to move on to number 2. All right, number 2 on this quiz, I've kind of set it up again. This is a quiz on the law of cosines. So you might say, let's use law of cosines. But if we didn't know it was law of cosines and we tried to use law of sines, what you're going to find is every fraction has something we don't know. So it's not going to work to start with the law of sines. So if we're going to do anything here, we probably want to start with the law of cosines. So if we do use the law of cosines, what we can see here is that if we call 160 degrees angle C, the opposite side length N would be side length C. And then again, A and B is side lengths 4.7 and 5.6. I don't care which is which because we're adding, we're multiplying, and that commutes. But we could plug those numbers in and we can write n squared equals all of this. And then looking there at the right side here, this is all just a bunch of numbers and operations. So again, if you want to break this down, you can. For the video, I'm just going to do all this on the calculator and say what is all that 4.7 squared plus 5.6, all that stuff. And I'm going to say n squared equals all this. So again, if I put all of this on the calculator, calculator gives me not quite 68, a little bit less, 67.959, etc. But that's what n squared equals. So I'm trying to solve for n, not n squared. So again, I have to take the square root of this. I'll do it here on the screen, but cancel the square with the square root. Whoops, let's get that back. Cancel the square with the square root. Square root of n squared, we'll do the square root of all that. And then on the calculator, I can say, all right, what is the square root of all of that? And I get 8.2437. 8.2437. It keeps going. Again, if you did intermediate rounding, you might get something that's slightly different, and that's okay. Just make sure you're showing your work. But again, we're going to the nearest tenth, so we're sitting at a 2 with a 4 next door, so we've got approximately 8.2. And in this case, that is centimeters is our measurement here for the side length. And this is, again, where without knowing more information, it is difficult to say whether or not this is reasonable. We would need to know one of the other angles, at least one of the other angles, to say is the big angle opposite the big side. Ooh, this one actually, sorry. We can say that since 106 has to be the biggest angle, kind of like in a right triangle where 90 degrees is the biggest angle in a right triangle, you can't have another angle that's 90 degrees or more. If you have an obtuse angle, 160 degrees, this should be the biggest side. So this one doesn't always work, but with an obtuse angle more than 90 degrees, we should get a side that's the biggest. So yeah, number 1, that didn't happen. 38 degrees is acute. I shouldn't get a biggest angle. Well, maybe not necessarily. Yeah, so this one is reasonable. We should get a biggest side here. Okay, all right, we'll flip the page here and we'll take a look at the next couple problems. So number 3 here, we're solving for an angle, but again, if this wasn't a quiz on law of cosines, if you thought maybe we should use law of sines, if you try it out, hopefully I've got the setup here, and you'll see that this is not going to work. Every fraction has an unknown. So instead, let's try law of cosines. So in this case, if we use the law of cosines, we probably want to assign angle H as angle C, and then opposite that, the 54 inches would be side length C. Again, side length A, side length B, the 38 inches and the 23, it's interchangeable. It doesn't really matter because you're doing addition or multiplication. But if you fill those in, we get the formula, we get the equation 54 squared equals 38 squared plus the rest of it, you can see. Now, here's where we want to be a little bit careful. So I'm gonna do some simplifying here. First thing you might want to do is you might want to chop slash this. You might want to say instead of minus 2 times the rest, you might want to say plus a negative 2 times the rest. Okay, so we did the plus negative, chop slash. We can square the 54, we can square 38, we can square 23. We can do the negative 2 times 38 times 23, and I realized I forgot to say cosine of h. But now the trick here is that we can combine that 1,444 and the 529, but this negative 1,478 is times the cosine. So think about order of operations. We're supposed to multiply that negative 1,700 whatever times the cosine before we do the addition or subtraction. So that's just going to stick around, and we're gonna cancel this other thing here. So my cheat sheet tells me when we combine the 1,444 and the 529, we get 1,973. And then what we can do is we can subtract 1,973 on both sides, leaving us on the right with the negative 1,748 cosine of h. And on the left, we come up with 943, according to my cheat sheet. All right, then this is multiplication. We can cancel that multiplication with division. Divide by negative 1,748. That'll cancel, leaving us with the cosine of h. And over here we balance. We divide by negative 1,748. And this is where, I mean, you can get the fraction on the calculator, or the decimal rather, excuse me, you can get the decimal on the calculator. So negative 0.539 whatever. But we're going to end up doing the inverse cosine of that. So I'll just jot down a few digits. So if you wanted to write this down as work, but now I have to cancel the cosine. So I'm going to do the inverse cosine to cancel the cosine. So I'm going to do the inverse cosine of that decimal. So if I go back to my calculator, and if I just left it on the calculator and I say, calculator, please do the inverse cosine of that, I get 122.647, and then my rounding instructions here, nearest whole degree. So 122.64. Keeps going, but to the nearest whole number, we got 122.6. That's going to be about 123 degrees as my answer there. Again, if we want to think about, is this reasonable? If this is 123 degrees, then it's an obtuse angle in a triangle. It's got to be the biggest. It's got to be the biggest angle, so it's got to be biggest the opposite side, or opposite the biggest side. And 54 is the biggest side. So it's reasonable. Again, it could still be wrong, but it checks out. If we had been solving for an angle opposite the 23 or the 38, and that came out to be a right angle or an obtuse angle, then I'd say that's not reasonable because the 38 inches is not the biggest side, so it shouldn't be opposite a 90-degree angle or an obtuse angle. Same thing with 23. But this is reasonable. It's hard to judge. Honestly, we've seen it with a couple others. It's hard to judge here. But all right, we'll keep going with number 4. All right, for number 4, I'm skipping over if you want to try law of sines, but what you'll find if you try law of sines is that you're not going to have enough information to get started. So probably want to try law of cosines. If you want to call the angle we're looking for angle C, the opposite side length would be side length C, and then the other two side lengths would be A and B. And again, those are interchangeable. Is A 10 or is A 7.1? Who really cares? It shouldn't affect our work. But if you want to put this in for time and space, I'm going to skip right in the formula. If you want to put these numbers into the law of cosines formula, okay, so if you plugged all those numbers into the law of cosines formula, you get something that looks like this. Again, if you want to chop slash and say plus negative 2, and then you can do a little bit of simplifying. So we can do 9.4 squared, 10 squared, 7.1 squared. We can do the negative 2 times 10 times 7.1, and we get 88.36 equals all of this. And then remember, we can do this addition. We can do 100 plus the 50.41, but we don't add the negative 142 because it's attached to cosine of k. So it's kind of order of operations or like terms. But what we can do now is we can subtract the 150.41 to cancel that, balance our equation. All right, and so what we end up with as an equation here, my cheat sheet says we get negative 62.05. That would equal negative 142 times the cosine of angle K. We can divide then by negative 142 to cancel the multiplication. And again, this is where I'll do it on the calculator, but we're going to get a decimal here, and I'm going to have to end up canceling the cosine of k, so I'm going to do an inverse cosine of k. Inverse cosine, rather, excuse me. So if you wanted to jot down a few decimals, 0.4369, etc., but we're going to end up doing the inverse cosine of that because we have to cancel the cosine over here. So cancel the cosine with an inverse cosine, then we're going to do the inverse cosine of this. I can squeeze that in, and then I can just ask the calculator if I want to leave that number on the calculator. I can say, calculator, what is the inverse cosine of that result? And I get 64.089. 64.089. It keeps going, and then we're rounding here. Our rounding instructions are nearest whole numbers, so 64.0. That's going to be 64 degrees. That would be our angle measurement there for K, 64 degrees. And again, this is difficult to judge if it's reasonable or not. Hey, should that be 64 degrees? I don't know, because well, it should be less than 90 because we don't have the biggest side opposite, but otherwise I don't know because I don't have the other angles. So it can be difficult to judge here without knowing more information. Okay, we got one more on this quiz and then we're all done. All right, number 5, we got a little bit of a story problem here about triangular garden. And so this is one way you might draw the diagram. The sides of 12 feet and 8 feet long. They meet at an angle of 42 degrees. How long is the third side? So again, if you have this story and you were able to get the diagram, if you try the law of sines, it's not going to work, not to get started. So we can use the law of cosines though. So with the law of cosines, 42 degrees being our known angle, if we call that angle C, then the unknown side length that we're solving for, I labeled it as x, that'd be side length C. Between the 8 and the 12 being side length A, side length B, those are interchangeable, but we have the equation x squared equals 8 squared plus 12 squared, all of that. We can do some simplifying. Again, the right side of this equation, if you want, you can just do everything on the calculator here to get x squared. If you want to break it down, that's okay. You might get a slightly different result. Just make sure you're showing your teacher your work. So if you do everything on the calculator, you come up with a little bit more than 65, 65.316. And again, if you want to leave that on the calculator, you can say, all right, I'm not done here, but I have to cancel the square. I'm going to take the square root. So I need the square root of that result. And we get 8.08, and we are supposed to round to the nearest tenth, 8.0818. This is what x would equal. And to the nearest tenth, we got 8.0 with an 8 next door, and that would be about 8.1 feet would be the third side of the triangle. Again, difficult to judge whether or not this is reasonable unless we have an obtuse angle or a right angle. So we would need more information to judge. But yeah, so I hope that video helped. See me in the next one.